So in this problem, you have a capacitor which is fully charged, and the potential or the capacitor voltage initially is 80 volt at the time t equals to 0. And now when the charge on the capacitor, you have to find it out what is the charge onto the capacitor when the current in the circuit is 33 microampere. So let's write down all the given information. The capacitance C is 22 microfarad. R is 1.5 mega ohm. Okay, and then this is the maximum voltage across the capacitor, which is when the capacitor at the time t equals to 0, and this is given by 80 volt. Okay, this is at time t equals to 0. This is the capacitor, the voltage at time t equals to 0. Alright, so now we can find out the initial current at time t equals to 0. Just when we press the switch, when you close the circuit, at the time the current in the circuit is given by, this is total given by this equation. This acts as the battery. Alright, but the battery voltage is changing with respect to the time. All the energy is now being dissipated in the form of heat. It is just heating up the resistor. At the time t equals to 0, this is the current that is flowing through the circuit. So let's plug in all the numbers here. This is 80 volt. R is 1.5 mega ohm. The mega ohm is 1.5 times 10 to the 6 ohm. 1.5 times 10 to the 6 ohm. When you do your math, the number you will get is 53.3 microampere. Alright, so 1 microampere, remember 1 micro is 1 times 10 to the 6. And now let's also find it out. We find out this is the initial current. Now let's also find out what is the charge onto the capacitor. That means at the time t equals to 0, we're finding out the charge. The initial charge Q naught is, you remember this formula, Q is equal to V times C. So this initial charge is represented by Q naught, and this is the initial potential across the capacitor, which is epsilon C, or the ideal the voltage at time t equals to 0. So the Q naught, this value is 80 volt, and the C is 22 microfarad. 22 times 10 to the negative 6. Whenever I say a microfarad, you see this means 22 times 10 to the negative 6 farad. So you just have to multiply these two numbers together, and the number you get is 1760 microcoulomb. So this is the initial charge onto the capacitor. Now let's find out the time constant. Time constant. The time constant RC is called the time constant. What's the value of R? 1.5 times 10 to the 6, and the C is 22 times 10 to the minus 6. If you do your math, the number for RC you will get is 33 second. This is the time constant. That means in order to discharge 33%, about 33% of the capacitor, the time it takes is 33 seconds. Out of 33 seconds, the charge or the current into the circuit will be reduced by 33%. When we have all this information now, we can find out the current into the circuit, and then we can also find out the charge onto this the charge. So now let's first find out how long does it take to reduce the current in the circuit to 33 microampere. I'll have to erase certain things. Let me erase this side here. Okay, let's start from here now. So the current at any point of time, the current into the circuit is given by e to the power minus t over r over c. Alright, now here my goal is to solve for t, because we know we have to find it out the time, how long does it take to get the current to 33 microampere. So this is 33 microampere, and initially we started with the current which is 53.3. That's the current. This is the time t equals to 0, and certain point of time you have 33. So what is the time it takes to get the current to 33? So that's the time I'm finding out. So this is 53.3 minus t over rc. Now e to the power minus t over rc. We know the value of rc too. rc is 33 seconds. So this is 33, and this is 33 divided by 53.3. Now I'm taking log on the both sides, so this will be t over 33 log 33 divided by 53.3. So I'm just taking the log onto the both sides. So now I have to erase this one too. So, and you can solve for the time. The time is 15.63 seconds. If you solve it, you'll get 15.63 seconds. So this is the time it takes for the current to go from 53.3 microampere to 33 microampere. We know now time as well. So how do we find out the charge now? The charge can be given by the same formula. Q is equal to Q naught e to the power minus t over RC. Everything we did just to calculate this time, because we do not know the time. This formula helps me to calculate the time, because I know the initial current when the time is 0, and then how long does it take to get to the 33 microampere. Just plug it into this equation now. Q, what is the initial charge? We calculated the initial charge. If you look at the initial charge, this value was 1760. E to the time is 15.63, and we also calculated the RC. The value of RC was 33 seconds. So the charge onto the capacitor when the current into the circuit is 33 microamp is 1100 microcoulomb. This is what you get. Alright, we'll let you